Sir, good afternoon.
Yeah, good afternoon.
Sir, that week 10 assignment solutions will be uploaded in the portal.
Week 10, yeah.
Was it uploaded or about to be uploaded?
I have not checked it. After, like you can check now, your evaluation will be done,
So,
whether it is
yes, I
done.
have clarification in the question number one, that is finding the next revised estimate ST.
You can ask the assignment question in that portal,
Oh, sorry.
in the forum.
Okay, sir. Thank you.
Okay, good afternoon, everyone. So today we'll take the week 11th of the Deep Learning IT Ropar course. So this is Abhishek Thakur, Prime Minister Research Fellow at IIT Hyderabad. So basically today we'll discuss about some of the important question from the week 11. So I hope everyone have watched the lecture from the NPTEL portal. If not, then you can watch this tutorial session now, or you can watch it. We will upload it on YouTube. From there also you can watch it later. So we'll discuss basically today question on sequential learning and RNN. So first of all, in sequential learning, the main thing we should keep in mind that the input is dependent on the previous input, as in CNN and feed forward neural network. Each inputs were independent. Like if we give a apple to input, then it predict output as a apple. If the next input is car, image of car, then there is no relation between the image of apple and car. So that was the case there. Let's wait for a minute. I will add pen. In sequential learning, the previous inputs, the means the current output depends on the previous inputs as well. Like if we predict the words, like let's suppose we predict D. So if we know D, E, then it is easy to predict that next word will be E. So that's why this is mostly used in speech recognition and the text recognition, sentence recognition, because the previous sentence or previous speech depends on the next part. So this is the application of the sequential learning, and each input corresponds to one time step, and size of the input is also not fixed. Like before, whatever we studied, the size of the input was fixed. Here the size is not fixed. Like in image recognition, what was there, like there was a 28 cross 28 sized image there. So but here size is not fixed because the word may have different text length according. So the size will be not fixed in the sequential learning problems. So coming to the first question, so that is based on the basics of sequential learning, and you can also answer the, if you know the answer you can answer in the comment box, or you can wait, I will also solve. The first question is, identify the application where the inputs are of fixed size and they are independent of each other. So there are four options. First is autocomplete application that recommends words to complete the letters you type. Second is image classification. Third is predict parts of a speech tag. Fourth is predict polarity of movie review. So here in this question you can see it is given that inputs are of fixed size and they are independent of each other. So as we know that a speech inputs are not independent of each other. Each words in the speech depends on the next word, and it is also not a fixed size. Here is the image classification task. Here image can be divided into fixed size. Let's suppose here it is 4 cross 4, and also the each part of the image is independent. Like each image is, sorry, it is image classification. So here it was a size part, and if we take two images, let's suppose the image of car or image of bicycle, there is no relation between both of them. Both are independent to each other. Model are trained accordingly. So for this question number one, option B is correct, that is image classification. If you have any doubt you can ask. or you can also write in the chat box. If no doubt, then we can move on to the next question, that is question number 2. So second question is also based on sequential learning problems. So the question is, choose the possible nature of input to a sequence learning problem. So we have to choose like what is the input for the sequence learning problem. So we have to see like which inputs are dependent to each other and have a not a fixed size. So text is one of them, speech is also one of them, and video is also one of them. So for this question, all of the above options are correct. So option D is the correct answer for this question. So these all are very basics and simple theoretical question. Now coming to the third question, it is pick out the application that does not belong to the sequence learning approach. So as we know that image recognition or face recognition, these things are not belonging to the sequence learning approach. These can be easily done using CNN. So here the option A is translate a single input language to several languages. So these language like translating of languages and all in this the input is not of fixed size. So this is depending on the sequence learning problem. So option A is wrong. Second is speech recognition. We have already talked about this. Third is face recognition. Fourth is stock market projections. So this these three are stock market projections. Also the in this also the current output depends on the previous inputs as well. In the face recognition, this does not belong to the sequence learning approach. So option C is the correct option for this question. Yeah, C is correct. Right. Now we'll move on to the question number fourth. What is the basic concept of recurrent neural network? So in this, it is asking the concepts of RNN. So we'll see all the options. The first is use a loop between inputs and outputs in order to achieve the better prediction. Use recurrent features from dataset to find the best answers. Use loops between the most important features to predict next output. Use previous inputs to find the next output according to the training set. So this option is correct, as you can see. Here you can see the block diagram also. In this you can see uh, this this W is depending on the previous input like x4, and here this W is depending on the previous input x3, and this W is depending on the previous input x2. So here it is using the previous inputs to find the next output according to the training set. So option D is correct. And the explanation for this is like after you train your RNN algorithm, it calculates the output according to our input only, and that it calculates input after input. Like it takes the previous input also in consideration. So if you have more than two inputs, like two or more inputs, it calculates the first output and consider it as next input to calculate the next output. Understood? So the option D is correct for this question number 4. If any doubt, then you can ask in between. So we move on to the question number 5. Or like if you have not seen this week 11 lecture, then you can watch on NPTEL portal. Then you can visit this tutorial session as well. And these videos will be uploaded on YouTube. So the next question is, for what RNN is used and achieve the best results? Like it is basically asking the application of RNN. The first is handwriting and speech recognition. So handwriting is correct. Speech recognition is also correct. We have already talked about this. Option B is speech and image recognition. So speech is correct, but image recognition is not, means RNN is not used to classify image or recognize image as a, means it is not the best way to classify or recognize the image. So option B is wrong. Option C is financial predictions. This can be true if like sometimes it depends on the previous inputs, but the option A is more appropriate here. And handwriting and image recognition. So here handwriting is correct, but image recognition is wrong. So option A is the correct option. And explanation for this is like RNN is great to recognize handwriting and speech, as we all know. Calculating each input like letter a word or second of a audio file, for example, to find the correct outputs. Basically, RNN was made to process information sequences. Yeah, correct, Raghupati. Option A is correct. Let me check whether recording of this video is going or not. Yeah, it's recording. So we'll move on to the question number 6. Before that, we will see recurrent neural network, like how it works. So in this, what happened? Let's suppose the first figure is there. This is one-to-one mapping. In this, what is happening? Like we are giving one input, and the function f1 is defined, which is taking an input x1 and giving the output y1. Similarly, in the second figure, you can see it is taking two input x1 comma x2, and a function f2 is defined in such a way that it is taking both the inputs and giving the output y2. Similarly, it can have three inputs and it can have multiple number of inputs. Okay, so the network is now sensitive to the length of the sequence. Like for example, a sequence of length 10 will require like function f10 as well, f1 to f10, whereas a sequence of length 100 will require all the function from f1 to f100. Okay, so these kind of things, what we do a connection here, like the from the previous input we connect and we make the network. This network is known as recurrent neural network, that is also known as RNN. So here our S is depending, that is the sigmoid of uxi, like x is coming here, uxi plus wsi minus 1. For this w, this is si minus 1. Okay, and plus the bias, and output is output of vsi, because we got si, so it multiply with si plus c. So this is our output, that is yi. So our output function depends on input xi, si minus 1, w, u, v, b, c. So we have the parameters here are w, u, v, c and b. So we have to update those parameters. Okay, so that we can do here using BPTT, that is back propagation through time. So that also you can study in the week 11 lecture. So now we'll solve one question. We'll see one question based on RNN. Like you are developing a sentence completion application that recommends words as you type each word. Assume you have typed I would. The model suggests the phrase like to bring to your notice. And if you type the word suggest next, then it should recommend a different phrase. Pick out the correct model to perform this learning. So these kind of like the next word prediction is done using the RNN only, as we have already discussed, because this CNN and all this is not used for the variable length input, and this is used for fixed length input as only. So here you can see that the model suggests, like if we typed I would, the model will suggest the next part, that like to bring to your notice. Okay, so this can be done easily using RNN, and it takes the previous input words and just predict the next output words. So this was very simple question. So any doubt up to here, up to question 6? So okay, so we'll move on to the question number 7. Before that, we'll see some of the dimensions of those parameters u, v, w. So here our x is n-dimensional input, that we assume that the input is n-dimensional, like x belongs to x1, x2, dot 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 xn. And s is d-dimensional. So here there will be s. So s is d-dimensional, And our y is, if let's suppose it is k classes, so y will be from y1 to yk. And what will be our v? See, y is k, so v will be like s is d. Here you can see s is d, so s is 1 cross d. Okay, and if we multiply with v into s, or you say, okay, let's suppose s is d cross 1 here, well, it is d-dimensional. So if you multiply v with s, then only you are getting output. So output is k. So what will be our v? 1 cross d, and okay, sorry, I have taken the transpose of it. S is our 1 cross d, and this s is multiplied with b. So 1 cross d, when it will multiply, when there will be like d row in the v, then only this column, d column in s will multiply with d row in the v. So the dimension of v will be b cross k, and after you multiply, our output dimension will be 1 cross k. So output is k dimensional, that is k classes. Okay, and our w is d cross d, because u is n cross d, because here you can see our x is 1 cross n, so u is multiplying, so u will be n cross d, because when you multiply x with u, we will get 1 cross d, that is our si, this si, and w will be r, that is d cross d. So these are just the dimension we should take care, and we will solve question based on this. So given a recurrent neural network shown in the figure below with the dimension here, that is xi is rp. Here in the previous example, what it was like it was rn, okay, but here it is rp. So x is 1 cross p. We'll write one by one and we will see. Okay, s is 1 cross q and y is 1 cross r. Okay, so what are the dimension of u, v and w? So here you can see x is multiplying with w, so 1 cross p, this is our x. If it is multiplying with u, so u will be p cross something. Okay, and our s is q, so u will be p cross q, then only our output will be uh, s is the like product of x u, so output will be 1 cross q, that is s. Okay, so u is the dimension of u is p cross q. Okay, now coming to v. So our output is k classes, so here it will be k, and v is like in the previous example, like you can see here that it was a k class, so v was d cross k. It depends on d, that is the dimension of s also, because s is multiplying with b. So here our s is 1 cross q. I will write it separately. S is 1 cross q, y is 1 cross r. So what will be v? V is equal to, sorry, s into b is equal to y. So s is 1 cross q, 1 cross r. So it will be q cross r. Okay, then only this like this is the dimension of matrix. Don't get confused. Like if a matrix of dimension 1 cross q multiply with a matrix of dimension q cross r, we will get a matrix of dimension 1 cross r. Okay, so what will be the dimension of v here? We have found it, that is q cross r. Done. Now the dimension of W, that is the square matrix of the dimension of S. So S is our Q, so W will be Q cross Q. So this is the dimension of U, B and W. Do you have any doubt? Yeah, Q cross R, that is correct. Okay, if no doubt, then we'll move on to the question number 8. If you have doubt, then you can ask in the YouTube session also, means YouTube comment box also, if you see this lecture again later on. So pick out the characteristics of R and N. First is account for dependence of inputs. That is correct because it accounts like inputs are dependent. Accept fixed number of inputs. Someone join me. So it accept fixed number of input. That is wrong. Where input size is variable. Different functions for every input. This is also wrong. Always output at every step. This is also wrong because sometimes it may not output at every step. And different parameter for every time step. This is also wrong. So option A is the correct option for the characteristics of RNA. So we'll move on to the question number 9. That is, pick out the ways in which BPTT, that is back propagation through time, is different from the back propagation. So the first is exploding gradient problem. We sum up gradients for corresponding weight for each time step. Third is vanishing gradient. Fourth is find product of all gradients. So what will be the correct option for this question number 9? So it is asking the how it is different from back propagation. So you can see the exploding gradient problem and this vanishing gradient. These two comes there also, and it finds the product of all gradients. We sum up gradients for corresponding weight for each time step. So the option B is correct because there also we find the product of all the gradients that we do the chain rule. So option B is correct for the question number 9th. Now we'll move on to the question 10th. That is writing the equation for the LSTM. These things is already in the lecture. If you see, then you will get it easily there. But in LSTM, there is three gates, that is write gate, forget gate, and read gate. So I will just write the equation for this. But if you want to understand this thoroughly, you can just go through the lecture. So this is for the output, that is sigmoid of W naught. So in this, basically what it happens, it selectively write some of the inputs and transfer to the next uh, like next part of the network, and after that it selectively read and selectively forget also. This helps in like to uh, ignore the redundancy in the data. So here this can be used, that is selective read, selective write, and selective forget is used, that is used by LSTM. So we'll move on to the next question, that is question number 11th. So this is just writing the equation for the GRU's gate. So in GRU's gate, what happens? Like the gates, there is no explicit forget gate here. So forget gate and input gates are tied together instead of forget gates. So there is no equation for FT here in this. So the equation will be only for the outputs and input, that is OT is equal to sigmoid of W naught ST minus 1. So in this what happened, there is no explicit forget get. This thing we should remember. The forget get and input gets are tied together. So for today, this much questions are only there. So we'll meet in the next weekend. That is the last weekend. I hope you all are watching and you have registered for the examination that will give you the certificate as well. I guess that is on the last week of this October month. Sorry, yeah, last week of this October month.
So, Mohan,
Yeah,
G, are you also thinking upon the HT minus intermediate value?
the gate depends directly on ST minus 1 and not the intermediate HT minus 1.
Good.
Okay, so thank you everyone for attending today's lecture. These videos will be uploaded on YouTube. If you have not seen now, so you can watch there. And if you have any doubt, then you can comment in the YouTube chat box or YouTube comment box, comment section also. We'll reply. Thank you everyone for attending. We'll meet next Saturday at 3 to 4. Thank you. Bye bye.